Hi dears, today we can see TRB maths in real analysis. First question, the set of all rational numbers is countably infinite. Second question, which of the following set is uncountable? Q is countable, N is countable, so N by N is countable, N cross N is countable, Z is countable, so real number is not countable. So the third question, set of all real numbers is not countable. That is the second one. Now third one, in a metric space, arbitrary union of open set is open, arbitrary union of closed set is closed, arbitrary intersection of open set is open. So first option is right, arbitrary union of open set is open. Now the fourth question, the sequence 0, 1, 0, 1, etc. has no limit point, has one limit point, has two limit point, has infinite limit point. So here 0, 1 are the limit point. So option C is the correct one. R with the usual metric is bounded, not totally bounded, not complete, compact. So here option D, compact is right. If A is open and B is closed, then A difference B is open or closed, or B difference A is open or closed. Let's see that. So first of all, here A is open and B is closed. So B difference A is equal to set of all X such that X belongs to B and X does not belongs to A. So that is X such that X belongs to B and X belongs to, X does not belongs to A, you can write as X belongs to A complement. So this and you can write as X belongs to B intersection A complement, right? So that B difference A is equal to B intersection A complement. So A is open, so its complement is closed. B is already closed. So intersection of closed set is closed. So B difference A is closed. Then we can see for A difference B, that is X belongs to A and X does not belongs to B. That you can write as X belongs to B complement. And that is intersection B complement. So B is closed given the question. So B complement is open. Again A is open given the question. Intersection of open set is open. So A difference B is open. So here option C is the right one. Then you can see the seventh question. Every bounded sequence has a limit point. Haidt-Borel theorem, Bolzano-Weierstrass theorem, Rolle's theorem. So every bounded sequence has a limit point, that is Bolzano-Weierstrass theorem. Eighth question, if a function f on closed a comma b is continuous, then differentiable on a comma b and f of a equal to f of b, then there exists, already we know that this is Rolle's theorem, right? So according to that we have f dash of c is equal to 0. So option B and C have f dash of c is equal to 0. But here it is given unique C and here at least one C. So option C is the right one. At least one C, at least on C between A and B, such that f dash of C is equal to 0. The next question, if f is a non-negative measurable function, then and integral over f is equal to 0 implies f equal to 0, f greater than or equal to 0, f not equal to 0, f equal to 0 almost everywhere. So option D is the right one. Then which is not uncountable. So 0, 1 is uncountable, minus infinity, infinity is uncountable. Then set of all irrational number is uncountable. Then here minus 1, minus 2, minus 3, etc. That is set of all negative integers. That is not uncountable. This is a countable one. Because we know that n is equal to 1, 2, 3, 4, etc. Here we have negative numbers, right? So these two have what? Same cardinality. These two have same cardinality. As well, we know that a set of all natural number is what? Countable. So if it's so, we can say that this is also countable. According to this, we can write not uncountable. So option C is the right one. 11th question, if fx equal to root 1 plus px minus root 1 minus px divided by x, with minus 1 less than x less than 0 and this for 0 less than x less than 1 is continuous at x equal to 0, then what about the value of p? So we know that for continuity, left hand limit is equal to the right hand limit. So here limit, x tends to 0 minus, because at the point 0. So x tends to 0 minus, this is the function. which is limit x tends to 0, the whole power 1 by 2 minus the whole power 1 by 2. This you can easily written as 1 plus ax the whole power n. You can write 1 plus n ax, right? Plus etc. So approximately you can write this as 1 by 2 px minus 1 plus 1 by 2 px divided by x. So by solving you will get which is equal to p. Similarly we have to see for the right limit. So 2x plus 1 divided by x minus 2. X tends to 0, you will get 1 divided by minus 2. The question given here is continuity. So continuity left hand limit is equal to the right hand limit. So the answer here is minus 1 by 2. So option C is the right one. Then 12th question, integral 1 to infinity dx by x is. So dx by x which is equal to log x from the limit 1 to infinity, that is log infinity minus log 1. So that we will get this is infinity which is divergent. Then 13th question, a compact metric space is uniformly bounded, totally bounded, is of bounded variation. So compact is totally bounded. Then if A is uncountable and B is countable, then A difference B is whether it is countable or uncountable or finite. So here we can see that A is equal to uncountable, right? And B is countable. A is uncountable. So we can take A is equal to R. R is uncountable and B is countable. N is a natural number is countable. Let's check that A difference B. That is R difference N. So in the set of real lines minus infinity to infinity, 0, 1, 2, 3, etc. minus 1, minus 2, etc. So here R difference N, you can understand that is minus infinity comma up to this one N, right? So 1 open N. 1 is not included. So minus infinity 1. This interval is uncountable. So we can write that A difference B is uncountable. So that 14th question, option C is the right one, uncountable. Then 15th question, set of all integers is open, closed, bounded, finite. So set of all integers is an. So here you can see that minus infinity to infinity, 0, 1, 2, 3, etc. minus 1, minus 2, etc. Let's check for the complement of integers. Okay. So that for the complement, this is the exact value 0, 1, 2, 3 are the exact value. So the complement of integers are 0, 1 because 0 and 1 is not included, right? Then 1, 2, then 2, 3. Similarly, minus 1, 0, minus 2, minus 1, etc. These are the complement of the integers. So in general, you can write n, n plus 1. If you put n equal to 0, you are getting this. N equal to 1, this. N equal to minus 1, you are getting this. So you can see the union of these intervals. So union of this open set, which is what? Open. So the complement is open, so that the exact set is closed. So we can write that set of all integers is closed. So option B is right. Then 16th question, if E is equal to closed interval 2, 5, then E bar is E. Because E is closed, we have the result that if E is closed, if and only if E bar is equal to E. Then 17, F from R to R defined by Fx is equal to 1 if X is rational, 0 if X is irrational, then it is exactly. Because in the set of all real number system, rational, irrational, which is not continuous at any point. Then 18th question, continuity on the set A implies uniformly continuity if A is finite, A is bounded, A is compact, then D option, A is closed. So this is possible only when A is compact. Because we have the result uniform continuity implies continuity. But continuity does not imply uniformly continuity. But this is possible only when the set is compact. If it is compact, then we can say continuity implies uniformly continuity. That is 18th question. Thank you.